My name is Mohammed Layiq Sediqi, the father of Holophase, and in this part we continue our story exactly from where we left off in the previous part of episode 4. Last time we did something quite bold together. We took energy, the proud king of modern physics, and gently moved it from the throne down to the desk where all the other useful tools live. We saw that energy is not a mysterious glowing substance inside things, but a beautifully consistent summary of how deeper patterns behave. And we met that deeper thing, a continuous rhythmic order I call the holophase, or simply Pi. In this part, I want to go further with you. We are going to walk through familiar pieces of physics, mechanics, waves, quantum phenomena, even a bit of cosmology, and see calmly and clearly how the everything is energy story both shines and breaks. And at each step, we will ask, if energy is not the ground floor, what does this look like from the point of view of phi? I want you to imagine that we are standing in front of a giant mural. This mural is the whole of modern physics. For centuries, we have admired it under one kind of light, the energy light. In this light, everything looks like amounts of energy being moved around and transformed. Now, in holophase, we take a deep breath, switch off that lamp, and turn on a different one, the phi light. The mural is the same equations, same experiments, same data. But under this new lighting, different features pop out. Patterns we barely noticed before suddenly become obvious. Others fade into the background. Our task now is not to repaint the mural. Our task is to walk along it with this new light and simply see. Let us start with something very simple. Throwing a ball. You stand in a field and toss a ball straight up. It slows down, stops for a moment, and falls back into your hand. In the usual energy story, we say, at the bottom, the ball has a lot of kinetic energy because it is moving fast. As it rises, kinetic energy is converted into gravitational potential energy. At the top, the kinetic energy is zero, the potential energy is maximum. Then the process reverses. Potential becomes kinetic on the way down. The total energy, kinetic plus potential, stays constant, minus small losses like air resistance. This is very useful. You can predict how high the ball will go from its initial speed. You can design machines, rockets, satellites, all using these ideas. But remember what we said. Energy is a number you compute from more basic quantities. To talk about kinetic energy, you measure the ball's mass and speed. To talk about gravitational potential, you measure its height relative to some reference level and use the gravitational field strength. The ball does not glow with energy substance. It simply moves along a path, and we attach numbers to that motion. Now, what does this look like in the language of phi? Here is one way to picture it. Imagine that behind the scenes, the ball and the earth are not things in a box of space-time, but localized patterns in a gigantic, invisible, vibrating ocean of phi. Each pattern has an internal rhythm, a kind of ticking, and there is also a background rhythm associated with the gravitational field around the Earth. When you throw the ball upwards, what you are really doing in the holophase picture is changing the relationship between the ball's internal rhythm and the surrounding gravitational rhythm. Close to the Earth, the pattern of phi has one kind of beat structure. Higher up, it has a slightly different one. The thing we call gravitational potential energy is, in this view, an encoder, a number we assign to how the phase pattern of the ball sits inside the phase pattern of the Earth's field. As the ball rises, the relationships between these patterns change. The apparent exchange between kinetic and potential energy is simply the way our old language describes changing phase relations. At this simple level, the two pictures, energy picture and phi picture, agree on all observable facts. The ball still goes up and comes down. The maximum height is the same. The time of flight is the same. If holophase could not reproduce that, it would be a joke. The difference is conceptual. In the old picture, you might be tempted to say, really, deep down, the world is made of energy. The ball is just a temporary configuration of energy in space-time. In holophase, we say, really, deep down, the world is made of phase relations. The ball is a stable, self-reinforcing pattern in phi. Energy is how we summarize certain aspects of that pattern under change. The reason this matters is not that it changes the path of the ball. It matters because when you move to more complex situations, the energy is everything language starts to get confused, while the phi first language stays sharp. Let's move to one of those situations, waves and light. Picture a very simple setup. You have a laser shining on a screen. If there is nothing in the way, you see a bright spot where the light hits. Now you put a thin barrier with two very small slits in it between the laser and the screen. Suddenly, instead of just one bright spot, you see a pattern of bright and dark bands, interference fringes. In everyday terms, all you have done is give the light two paths to reach the screen instead of one. Yet the result is not just twice as bright, it is a pattern of reinforcement and cancellation. How do we usually describe this? We say light is a wave. The waves going through each slit overlap. Where the peaks from one path line up with peaks from the other, you get bright bands. Where peaks meet troughs, they cancel, and you get dark bands. If we speak energy language, we might say the energy of the light is distributed in a pattern because of interference. But think carefully. The total energy coming out of the laser is basically the same whether you open one slit or two. Yet the way that energy arrives on the screen is radically different depending on the phase difference between the two paths. If you very slightly change the distance of one slit, the entire pattern shifts. The energy didn't change, the phase relations did. This is one of those places where energy gives you a correct budget, but it does not tell you how the pattern looks. The heart of the story is in the phase. Now imagine turning on the holophase light here. In the holophase view, what you call light is a particular pattern in phi, a coherent oscillation. The two slits simply create two routes for this oscillation to reach the screen. Each path imprints its own phase twist on phi. When these routes meet at the screen, you are literally looking at the way phi from one path and phi from the other path combine. The bright and dark fringes are not mysterious. They are where the phi pattern reinforces or cancels itself. The only reason energy appears in this story at all is because the brightness, the amount of light you see, scales with how strongly the pi patterns add up. The energy is following phi, not the other way around. The crucial insight here is this. You can keep the total energy fixed and completely rearrange what actually happens just by changing phases. If energy were truly the deepest ontic substrate, that would be very strange. How can the real substance of the universe stay the same while reality's actual appearance transforms radically? In the holophase picture, this is perfectly natural. The underlying stuff is not a scalar quantity like energy. It is a structured phase field. Rearranging its structure while preserving some overall measure is exactly what you expect. Now let us drop down to an even more shocking level where quantum mechanics lives. You have probably heard of the famous double-slit experiment with single particles. You send electrons one by one through a double slit. You might expect them to behave like tiny bullets and just form two clumps on the screen. Instead, if you let the experiment run long enough, they form an interference pattern, as if each electron is exploring both paths and interfering with itself. In textbook language, we talk about the wave function of the electron. That wave function has an amplitude and a phase. The amplitude squared gives us probabilities. The phase controls interference. Two regions with the same amplitude but different phases can give totally different patterns on the screen. Notice again what is really doing the work here: phase differences. You can have the same energy, the same amount of wave function spread, but different arrangements of phase and nature will give you different statistical outcomes. If your ontology only says the world is made of energy and particles in space-time, you have to bolt phase onto that picture as a strange extra ingredient. It becomes a mathematical trick you use to make predictions, not the thing you declare to be real. Holophase reverses the priority. In holophase, the fundamental object is phi, a global phase field. What we call a quantum state is a particular configuration of phi across different possibilities. When you see interference patterns, what you are seeing is how those configurations in phi interact with the measuring device, which is itself a phi pattern. Probability in this view is not some mysterious magical rule attached to energy levels. It is a way of counting how often certain phase configurations lead to certain outcomes across many windows of observation. The rule that probabilities depend on the square of an amplitude, which in turn is deeply tied to phase, becomes natural rather than arbitrary. The important point for our current episode is this: the structure of phase is doing the heavy conceptual work in quantum phenomena. Energy remains a very important bookkeeper. For example, Different energy levels in atoms correspond to different stable phase patterns. But the life and death of quantum behavior, interference, entanglement, phase transitions, depends on how phi is arranged, not simply on how much energy is present. That is why, in cutting-edge experiments, physicists talk so much about coherence, visibility, relative phases, phase locking, geometric phase, and so on. Even inside mainstream physics, long before holophase, phase has been quietly acting like the real conductor of the orchestra, while energy has been credited as the composer. Holophase simply says, let us stop pretending. Let us admit that phi, this hidden, continuous order of phase, is the true ontic player. Let us treat energy as one of its most powerful tools, but not as the substance of reality. Now, let us zoom out to two of the biggest cracks in the energy is everything story, the vacuum and the whole universe. First, the vacuum. In classical physics, the vacuum was empty space, no particles, no fields, nothing. If you asked, how much energy is there in a truly empty box? The answer would be zero, by definition. In quantum field theory, this picture changes. Even in the lowest possible state, fields still fluctuate. There are always tiny jitters in the underlying fields. If you ask, how much energy is associated with these fluctuations? And you do a naive calculation, you often get absurdly large numbers, so large that if they were real, the universe would have torn itself apart long ago. To repair this, physicists use subtle mathematical tricks. They subtract infinities, they renormalize, they say only differences in energy matter. Operationally, this works extremely well for predictions in particle physics. But the underlying question remains awkward. If energy is the fundamental stuff of reality, why does our best theory keep predicting ridiculous amounts of it in empty space? Are we sure we are even asking a meaningful question? From the holophase perspective, the problem looks different. Instead of asking how much energy is in the vacuum, we ask, what is the structure of phi in this region, and what aspects of that structure are actually visible to our instruments? Phi can have many microscopic variations that simply do not show up in any possible measurement. From the holophase point of view, unmeasurable variations are not part of the physical story. They are part of the mathematical background, not the operational content. What matters is how phi behaves on windows where experiments can probe it. Vacuum energy then becomes not the literal energy filling space, but a certain encoder we construct from the accessible phase structure. If our formulas assign huge numbers to unobservable parts of the model, we do not panic and say, reality is filled with absurd energy. We say, our encoder is counting the wrong things. We should redefine what we count as physically meaningful. In other words, holophase builds from the ground up with a question that energy-first ontology often forgets to ask. Which aspects of the model are actually read by instruments, and which are just artifacts of the way we wrote the equations? Phi is always tied to what can be reconstructed on windows of observation. Energy, in contrast, is often extended in imagination beyond what can ever be measured, and then we get paradoxes. Now look at the entire universe. In general relativity, energy is tied to curvature. The way space-time bends depends on how energy and momentum are distributed. Locally, this works beautifully, but if you ask about the total energy of the universe as a whole, things become subtle. In many realistic cosmological models, there is no agreed unique way to define a global, conserved, total energy of the universe. Of course, you can still compute energy in local patches. You can still talk about energy densities in matter, radiation, dark energy. But the idea that there is one clean, global energy number for the entire universe starts to wobble. If you grew up thinking everything is energy, this wobble is unsettling. If energy is the one true substance, surely the total amount of it should be well defined, sharp, unambiguous. The fact that it is not suggests that energy might not be the right primitive language at cosmic scale. In holophase, this is less distressing. Phi is not a certain amount of stuff. It is a global phase structure that can have very different kinds of large-scale behavior. The important invariants are patterns, cone structures, how signals propagate, how phase winds around big loops, what kinds of defects and topological structures exist. Some parts of that structure can be summarized locally as energy densities, but other parts cannot. So, instead of insisting on a single global energy value, Holophase emphasizes the consistency of phase dynamics across scales and windows. The question becomes, is there a single coherent set of phase dynamics that accounts for all the patterns we see, from particle experiments to galaxies and the cosmic background? If such dynamics exist and are stable under careful tests, then energy emerges as one coherent set of summaries. If not, we must refine our picture of phi. Now, let me step back and ask you to notice something. We have not denied a single successful prediction of energy-based physics. Balls still fall. Engines still obey efficiency limits. Lasers still work. Quantum experiments still match the statistics predicted by standard theory. Holophase would be worthless if it did not reproduce all of that. What we have done instead is shift the story in which these facts live. We have said energy is always computed from more basic observables. In many crucial phenomena, phase relations, not energy, determine the actual pattern of outcomes. Energy language struggles or becomes ambiguous in some of the deepest areas: vacuum, cosmology, quantum measurement. A phase-first ontology, like holophase, treats these problem areas as natural because the primary object is not how much stuff, but how the underlying rhythm is arranged and changes. This leads us to a natural question, and it is the question that keeps this entire project honest. How could we tell, in principle, whether the world is really more like an energy-substance story or a phase-first story? In other words, is holophase testable, or is it just a poetic rephrasing? The answer must be holophase is testable. Otherwise, it is just philosophy. At the introductory level, let me give you the flavor of what such tests look like without going into technical details. Imagine two rival worldviews. Worldview A says, at the deepest level, everything is energy in spacetime. Phase, interference, coherence. These are convenient mathematical tricks on top of energy. Worldview B says, at the deepest level, everything is a phase field, phi. Energy, spacetime, and the rest are convenient encoders built on top of phi. Now, in many simple situations, both worldviews will make identical predictions. That is why they both survived so long. You can describe a pendulum either as a lump of energy sloshing between kinetic and potential forms, or as a phase point moving around a circle. Both descriptions match. At that level, it is a matter of taste. The interesting tests live where the descriptions diverge in clarity, consistency, or predictive structure. Here are a few examples of the kind of differences holophase expects. First, experiments where energy stays fixed, but phase is manipulated. If energy were truly fundamental and phase were just a human trick, then once you fix the energy of a system, you might expect that all physically meaningful behavior is already determined. In practice, we know this is not true. You can fix the energy in an optical setup and, by changing phases along different paths, dramatically alter interference patterns. Holophase predicts that as we push these kinds of phase control experiments into more extreme regimes, more paths, more dimensions, more coupling between systems, we will find patterns and constraints that are easier to state in phi language than in energy language. We will find, for example, that there are clean phase-based conservation-like rules for certain interference structures even when energy talk becomes muddled. Second, domains where energy becomes ambiguous or renormalized away, but phase remains sharply defined. In very high energy physics, in certain condensed matter systems, and in aspects of quantum field theory, energy often appears only in differences. Absolute values are subtracted, thrown away, or regularized. From the holophase point of view, this is a symptom that the theory is trying unconsciously to get rid of the part of energy that is not directly tied to observable phase structure. Holophase predicts that when we rewrite these theories explicitly in phi language, some of the mysteries behind why we subtract this infinity but not that one will turn into clear statements about which phase structures are actually visible in windows of observation and which are pure gauge, that is, unphysical redundancy. Third, global tests that combine many scales at once. Holophase is not just about local experiments. It insists on a single, coherent narrative from the smallest scales to the largest. That means that any ultimate version of it must fit cosmology, particle physics, condensed matter, and information theory into one phase-based framework. Worldview A Energy first currently has a hard time doing this cleanly. Different domains often use different notions of energy, different regularizations, different effective theories. Holophase makes concrete claims about how these domains arise as different ways of reading one underlying phi. Those claims lead to specific relationships between things like interference patterns in the lab and large-scale structures in the cosmos. If those relationships do not hold under observation, holophase is falsified. I am not asking you to hold all of that in your head yet. At this stage, just feel the attitude. Holophase is not asking for special treatment. It is not asking to be believed because it sounds deep. It wants to be attacked. It is built to be attacked. If someone can demonstrate a robust, repeatable phenomenon that absolutely requires energy as a primitive concept, that cannot be re-expressed as an encoder on phase, then holophase must bow out. If someone can show a domain where phase is obviously not the central player, where all interference, coherence, and phase structure can be rewritten as harmless decorations on a pure energy story, then holophase loses its purpose. That willingness to be wrong is what makes this a scientific model and not just a spiritual metaphor. As we move towards the end of this part, I want to bring the story back to you, personally. Why should you care about whether the universe is made of energy or made of phase? You might say, as long as my phone charges, my kettle boils, my GPS works, does it matter which deep story we adopt? The devices are built on the energy story and they work. Here is my honest answer. For everyday life, maybe it does not matter. For building a toaster, holophase will not help you more than classical electromagnetism. For designing a bridge, the old language is enough. But for understanding what reality is, for understanding where you sit inside this universe, for understanding consciousness, meaning, time, information, the limits of knowledge, the origin of laws themselves, the foundational story matters. If you believe that everything is energy, you will tend to think of your own mind, your experiences, your relationships, your culture as elaborate rearrangements of a single substance. That can be a useful framing, but it also flattens many distinctions. It tempts you to think that once you know all the energy distributions, you have explained everything. Yet, many people feel intuitively that something is missing in that picture. Holophase offers a different core intuition. It says, the universe is not made of stuff. It is made of order. Not order in the sense of neatness, but order in the sense of structured rhythm, structured phase. You are not a lump of energy in space-time. You are a very specific, incredibly intricate pattern in phi, a pattern with memory, with feedback loops, with the ability to model other patterns, including itself. In that story, energy is not cheapened. It becomes one of the most important summary tools that complex phi patterns have discovered about themselves. It is how some parts of phi measure and constrain other parts. But it is not the primary miracle. The primary miracle is that there is a coherent, evolving phase structure at all. In the next part of episode 4, we will tighten the screws even more. We will go through the core claims of the energy is fundamental worldview and challenge them one by one in simple but precise language. We will show how, from the holophase viewpoint, treating energy as the ontic substrate is not just unnecessary, but actively misleading in some key areas. And we will keep asking the same question. If phi is real, how would this look? And what experiments could prove us wrong? For now, I invite you to let one final image settle in your mind. Imagine two people standing at the edge of a vast ocean at night. One person says, this entire ocean is made of water. Water is all there is. The waves, the foam, the spray, the currents, all just water behaving in different ways. If we know how much water there is and how it moves, we know everything. The second person listens, nods, and then says gently, look again, the ocean is waves, the water is the medium, the reality is the rhythm. In holophase, energy is the water, phi is the rhythm, and everything you have ever seen, felt, or thought is a pattern in that rhythm.